Okay, now dear student, today we will solve our another NCRT exercise questions. Now we are doing our fifth question. Okay, now look at this question. It is asking about how is a voltmeter connected in a circuit to measure the potential difference between 2 points. As we already discussed about voltmeter and ammeter. As we know, we use voltmeter to measure the potential difference, and we use ammeter for measuring the electric current in the circuit. And one very important thing, that voltmeter always connected in parallel combination to the circuit, and ammeter is always connected to the series combination of the circuit. Okay, so answer of this question should be voltmeter always connected to parallel combination to the circuit, or you can say a voltmeter is always connected in parallel to resistance across the point between which the potential difference is to be measured. Okay, now sixth question is this, that a copper wire has diameter 0.5 mm and resistivity 1.6 into 10 to the power minus 8 meter. Okay, look at here, it should be 1.6 into 10 to the power minus ohm meter. Remember this thing, don't write blindly anything. Okay, in this question it is saying about that the copper wire, we have copper wire, its diameter is 0.5 millimeter. Okay, and resistivity it should be 1.6 into 10 to the power minus 8 ohm meter, then correct it. Okay, what will be the length of this wire to make its resistance 10? What is 10? 10 is nothing, you know this thing. Question is 10 ohm. Okay, how much does the resistance change if the diameter is doubled? Okay, uh, in this question it is asking about two things to us. That first thing, we have to find the length in this question of that copper wire, first thing, and the second thing, we have to find about the resistance when diameter will be doubled. Okay, now at first look here, we have diameter, that is 0.5 millimeter, no problem. We have resistivity in this question, that is 1.6 into 10 to the power minus 8 ohm meter, and we have resistance 10 ohm. At first we have to find the length of that wire. So as we know, we have formula R equal to rho L upon A. This is formula for resistance. Okay, R is resistance, rho is resistivity, L is length, and A is area. Okay, very important point, it should be noted here that we have a value of resistance, that is 10 ohm. In this question we have resistivity also, that is 1.6 into 10 to the power minus 8 ohm meter. We have to find a length, but what about area? So such type of question will come in your board exam. Definitely it comes in it comes in our board examination. So remember one thing, we should remember this formula. Okay, R equal to rho L upon A. How can we find area of any wire? Okay, there should be some formula. I'm talking about that formula. Area of any wire will be pi r square. You know, you are well known about this formula, that what is pi r square. This is area of circle. Okay, in case of area of any wire, because we take always cross sectional area and we have formula for that, pi r square, you can blindly use this formula for area of wire, that is pi r square. And you know about pi, that is constant value, which is 22 upon 7, as we say this thing, that, and r, that is radius. Okay, so in any question, if we have to find the area of any wire, then we directly use pi r square formula. Okay, now we are able to give answer of this question, that we have this formula R equal to rho L upon A, as we have diameter 0.5 millimeter. Okay, well, we have to find area, that is pi r square. We should have radius. Okay, how can we find the radius? Radius R equal to d upon 2. As we know, when we do a half of diameter, we get radius. So we can find the value of radius in this question also. But here you can see resistivity is given, and look at unit is okay or not, ohm meter. Okay, this is SI unit of resistivity, no problem. Look at resistance, that is 10 ohm. No problem here also, because SI unit of resistance is ohm. But problem is this, that diameter is given in millimeter. So we will convert this millimeter into meter. And we should know this thing, that when we convert millimeter into meter, then we will multiply by 10 ki power minus 3. Now it is converted into meter. When we convert millimeter into meter, then we will multiply with 10 to the power minus 3. Okay. So now we have diameter, we have resistivity, we have resistance. We will use this formula. Now we will put all value here, then it will come 122.5 or 122.7 meter. That will be our answer. Remember one thing, what we have to do, R equal to rho L upon A. Okay, then we will do R equal to rho L upon pi R square. Okay, we have R, we have rho, we have to find L, we know about pi, we can find out the value of R from here. How? R equal to D upon 2, like it. Okay, then we will get our answer 122.5. Now another part of this question is that, and this is also very important part, how much does the resistance change if the diameter is doubled? If we double the diameter of that wire, then what will be the effect on the resistance? As we know that resistance depend on length, resistance depend on area, like it. So what about the relationship between resistance to diameter? So we can find this relation from this relation. Okay, how? As I already told you that area we can write pi r square. So it means this is constant term. I can say r proportional to 1 upon r square. It means that resistance is inversely proportional to the square of the radius. It related to the radius, like it. And if we want to relation with this to diameter, so we can do one thing, because we know r equal to d upon 2, and this term is also constant. Okay, so when we use proportional sign, then we will not use any constant. Okay, now r proportional to 1 upon d square we can write here. So r is inversely proportional to d square. In this question, it is asking about when diameter is doubled. Okay, now suppose this is a condition, r proportional to 1 upon d square. When we double the diameter, what will happen? Then resistance will change. Suppose it will become r dash proportional to 1 upon double 2d square. So it will be r dash proportional to 1 upon 4d square. So it will become 1 upon 4. Okay, 1 upon 4 of the original value. Here it is. Okay, now we have in this question resistance is 10 ohm. Then we will do 1 by 4 of 10. 10 upon 4, that will be 2.5 ohm. Now look at question number 7. The value of current flowing in the circuit resistor for the given resistor. Okay, in this question he has given us value of I and value of V. We have to draw graph. Make one thing, make graph, right here V, right here I. Okay, and in graph paper, as we know that current 0.5 ampere, 1 2 3 4, it means that there should be 0.5 like it, 1 1.5, 2 2.5 like it. In volt we have 1.6. Okay, we can write 1 2 3 4 5 or 2 4 6 8 10 like it. So we can draw graph from here. That graph will be like it. Okay, maybe some curved may be there. Okay, it's not compulsory that it will be straight line. Straight line comes only in the ohmic conductor. When we do experiment with the ohmic conductor like copper, silver, then straight line curve come, but it doesn't matter that it come straight line or not. But when you will solve this one, definitely there will be some curve. At first you have to draw graph. Okay, now in second part, asking about calculate the resistance of the resistor. Okay, so how can we calculate the value of resistance? As we know from Ohm's law, when we draw graph between V and I, okay, graph is like that, we will find the slope of this graph. When we will find the slope of this graph, then we will find resistance. And how can we find the slope of that graph? Suppose take this point, draw perpendicular here. Suppose this point A, this point B, so and this point C. So slope will be AB upon BC. It will be resistance. Okay, from any line you can draw. If you will draw from here, okay, suppose this is D, this is E, so resistance will be DE upon CE. Answer will be same. Remember this thing. Okay, so we will draw VI graph, and the slope of VI graph always represent resistance. Okay, but here you can see he is making IV graph, and in IV graph we will not get value of resistance. In IV graph, when we will find the resistance, then we will find the 1 upon R. So always draw graph VI. You have to draw graph VI, not IV, like it. VI graph and find slope, that will be resistance. In IV graph, when we will find the slope of this one, it will be 1 upon R. Then we have to reciprocal it, then we will get our answer. So directly do this thing, draw VI graph and find the slope of that graph. You will find the value of resistance. Now next question, question number 8. When a 12 volt battery is connected across an unknown resistor, there is a current of this. Find the value of resistance of the, okay, no problem here. We have V is given, that is 12 volt. You can see here I is given, that is 2.5 milliampere. That is in milliampere, it should be in ampere. 2.5 into 10 की power minus 3 ampere it should be. Okay, so we can do also this thing. We have to find R, then directly we use R equal to V upon I. We will put the value and we will get our answer. No problem in it. Next question. A battery of 9 volt is connected in series with these resistances. How much current would flow through the 12 resistors? Okay, no problem. These are connected in series. Okay, these 5 are connected in series. So in series combination, we can find the total resistance by adding them. R equal to R1 plus R2 plus R3 plus R4 plus R5, like it. Then we will get 13.4 ohm. So we have to find a current in this circuit. We know from Ohm's law, that is V equal to IR. We can find I equal to V upon R. We have V, we have total R. After solving this, we will get this current 0.67 ampere. Then we have total current in the circuit. So now it is asking about how much current would flow through the 12 ohm resistor. Okay, it should be 12 ohm resistor. This is 12 ohm resistor. Remember this thing, when we are connecting in series combination, it means that 1, 2, 3, 4, 5, okay, like it. Suppose this is 0.1, this is 0.3, this is 0.1. Total current is 0.67 ampere. We already find. So this current will move to 0.2 ohm also. This will move also 0.3 ohm also. This will move also to, because in series combination current remain constant. So in every resistor current will be same, that is 0.67 ampere. Okay, in this question this is 12 ohm resistor. Okay, it is asking about how much current would flow through the 12 ohm resistor, because 12 ohm is here also. So this is very important. Who is writing blindly without thinking, without doing anything, okay, definitely he is not getting anything there. We have to do practice for it. Okay, we have to listen all the things like it. So solve these questions at first, then we will solve another 2 or 3 remaining questions. Thank you.